Good morning, friends. It gives me immense pleasure to again start my next class of aircraft systems. My topic for this is power generation and the distribution. I am Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I am in the case study section, problem solving in aircraft systems, and I have completed in this section, I think 9 to 10 classes, and a little description of this power generation and the distribution was already covered in module 2. However, again, I will refresh here and a more detail on that I am going to discuss about that. I am going to cover these topics. Power generation, it is CO2. Primary power distribution, also CO2. Power contactor. Power conversion and energy storage. Secondary power distribution. Typical AC and the DC systems of the aircraft. These topics I am going to cover in the following slides. Power generation, we can make it into the two groups. One is the DC power generation, another is the AC power generation. Here if you see DC power generation, DC system use generators to develop. DC voltage we use 28 volt DC. Also sometimes we use the 270 volt DC. Regulated for 28 volt DC. DC generators are rotating electromagnets. Conversion of DC is done by the commutator. Sine wave AC converted to half wave rectified. Aircraft generation are shunt wound with high resistance. So these are the characteristics of the generator. Here this you can see that this is the reference I am writing as a 2. So this you can see here that here we have a generator. This generator is shunt wounded. Here we have the terminal. So DC power generation we use 28 volt DC we generate. However, for some US military aircraft, especially the F-22, F-35 uses 270 volt DC. This I have discussed in my previous classes. DC generators, here we have the magnet and here we have the coil. So this has to be rotated by some engine. After this rotation, the current will be generated and here it will be made like this. This is AC. This is the DC. Sorry, this is the DC generators. It is generated. DC voltage regulator. So how we can generate the DC voltage? So here we use the shunt generator voltage to drop with increasing current and output voltage should be constant. A voltage regulator is used to modify the current, so voltage is maintained constant. So in this what happened? We use the resistance. So if we increase or decrease the resistance of the, so voltage will remain constant. So if you want a 28 volt DC, we will make sure that here voltage increase. If you shift from here to here, this if you make here, it is the highest. And if you shift from here to here, it is the lowest. So it is a rehosted type of systems. And if you, and this is the shunt, and here is the generator. These things are to be used. So shunt generator voltage to drop with increasing current and output voltage should be constant. A voltage regulator, this is the voltage regulator. Here is the voltage regulator. Okay. So AC power generation, how the AC power will go like this, and DC will go like this, Oh, that is the difference. So an AC system use generator to generate a sine wave of a given voltage with constant frequency. Here we maintain a frequency constant. Construction is simple than DC generator due to absence of the commutator. In this we don't have the commutator. Slip ring used to pass current from rotor winding. AC generator works. So if you see here we have the power sources are here, rotating excitant rotors are here, and here is the raw AC power is coming. It is generated DC excitation, and in this way the principle of operation of modern AC generators are used. Three-phase AC generator. If you see here, this is the phase 1. This is the phase 1. This is the phase 2, and this is the phase 3. ABC. It is generated. So voltage is minus 115 volt AC. So 200 volt AC. This is the neutral point here, and from here 3 phases are taken like a star. So most aircraft generator generate 3-phase, that is the 3 sine waves. This you can see, this is the phase 1, this is the phase 2, and this is the phase 3 IABC. So 3 sine waves are generated with a 120 degree out of phase. So just you can see, this is the 120, this is the 120, and this is the 120 degree out of phase, connected with star configuration with one end neutral, and all are joined as a neutral. The phase voltage we want 150 volt AC. The frequency for the aircraft is 400 hertz. So we want 115 volt AC with 400 hertz of the frequency. This we want because as much you have the high frequency, that much smoothness of the alternating current you can observe. So here we have this, you can see it is very low here. If you see the household or industrial use our AC, it is 440 volt 50 hertz. This is the, and for house it is 220 volt 50 hertz. This is for the house, okay, household, and this is for the industry use, 3-phase industry use. So this is the 3-phase AC generator. Now power generation and control. So how we can generate the power and how we can control the power. So that is the objective of this slide. We have here DC system. In DC system we have the voltage regulation, we have the parallel operation, we have the protection function. So in DC, first thing, voltage should be regulated. Then parallel operation has to be performed and the protection of the system has to be done. If you see here in AC, this protection is changed to the supervisory. Another system is required which is much better than much safety needed for the AC system, because in AC system we need the supervisory function. So this voltage regulation, parallel operations are same, but this is not same as this. So in this little variation that we are going to discuss in next few slides. So DC system power generation, voltage regulation of the DC. So how we can see that this thing is done. So as shown in this, it uses variable. This we can see here. This is the diagram. Okay. So in this diagram, how the resistance is changed, or how these things are varied. We want a constant voltage. So in this, a resistor is used. This resistor will make sure that voltage is constant. We want here a constant voltage, but if you want to increase or the decrease, this part you have to change it, and then you will get the required value. So it uses variable resistor in series, hence voltage and the current may be varied as per the load and the engine speed. DC system limited to 400 amperes and 12 kilowatt per channel for 2 regions. So it is limited. In DC can go up to 400 amperes and 12 kilowatt per channel for 2 regions. So what are these 2 regions? Size of the conductor and the switch gears to carry the necessary current. So if we are going more than this, the size of the switch gears and the necessary wires has to be more. The brush wear on brushed DC generator becomes excessive. If we generate more than this rating, then it becomes very excessive. Your brushes will be spoiled very soon with resulting maintenance cost if these levels are exceeded. So if the current level is more than 400 or the power is more than 12,000 watts, then the maintenance cost will also increase. The size of the switch gears, the size of the your wires will also increase. So it is a voltage regulation, how we are doing. The second is the parallel operation. So how we do the parallel operation? No break or uninterrupted power from each generator is needed. So if break is there in one generator, it has to give to another. If another one is failed, it gives to another. Means power should be uninterrupted. Otherwise, your system will stop working. If not, some sensitive electronic equipment may be disturbed. So if we are not able to maintain uninterrupted power supply, and so if not, this is not, some sensitive electronic equipments may be disturbed. So if it is fluctuating and it is on off and all, your fuses may go, your system may stop. So it should, at any condition, uninterrupted power supply should be there. This is called the parallel operation. So parallel system should give equal proportion of load to each and every system. So how this parallel operation is done on the system, it is explained here. So if it is a generator G1 and here is the generator G2, here is your voltage regulator, here is also this voltage regulator. Power will go like this, from here it will come and then it will go here, and equalizing coils are here, and this, if it is, it will go here and it will go here. So it can go from this side to this side or this side to this side, and this will supply to the number 1 DC bus and number 2 DC bus. So it is a parallel system, has to be maintained at any cost. If one is failed, G1 will work. If G1 is failed, G2 will work. And this will give to this one also and this one. Power will give to this and this will also give to this. This is called the, and here we have the paralleling contacts. So this contact will automatically, it will be made. It is uninterrupted by any human interference is not given. So primary power distribution, if you talk, the primary power distribution system consolidates the aircraft electrical power inputs. In the case of typical civil airline, the aircraft may accept power from following sources. Main aircraft generator, these are the sources of the power. So main aircraft generator by means of a generator control breaker GCB under the control of the GCU. Alternate aircraft generator in the event of generator failure by means of a bus tie breaker under the control of the bus power control unit. Auxiliary power unit generator by means of APU GCB under the control of BPCU. Then there is a ground power by means of an external power contactor EPC under the control of the ground and the power manager. So what are these things? First is the main aircraft generator. In normal it will apply. If this main is failed, alternate aircraft generators will work. If this is also failed, APU generator will work. And another one is the ground power. This is working on the ground. So these first three, they can be used on aircraft, but the fourth one is only used on the ground, especially for maintenance and some other activities. These power sources are used. So backup converters, we have another one is the backup converters by means of a converter control breaker under the control of VSCF converting, Boeing 777 only, random access turbine, random air turbine generator when deployed by the emergency electrical system. We have the power contactor. This we can see here that contactors are used where normal rated currents are greater than 20 amperes per phase, that is for load of around 7 kVA or greater. So this, if it is 20 amperes or more, or the load is 7 kVA, that time these contactors are used. So this ELCV has inbuilt current sensing coil that enables the current of all three phases to be measured. So this ELCU is here, and this ELCU will make sure that it is sensing. There is a coil, and this coil will sense the load. Accordingly, it will make the system on or off. So here power contactors are here. ELCU are smart contactors are nowadays used, and they are depicted in this diagram. Power conversion and the energy storage. So it is required to convert power from one form to another. Typical conversion from DC to AC power. This conversion uses units called the inverters to convert 28 volt DC to 115 volt single phase or three phase powers. Conversion from 115 volt AC to 208 volt to 28 volt DC power. This is much used conversion using units called the transformer rectifier unit. This converts, like in our UPS, in our lab and in our home and all, UPS are used. So they are converting from AC to the DC. Same way in aircraft, this is called the transformer rectifier units. They are converting from 115 volt AC to 28 volt DC power supply. Conversion from one AC voltage level to another. A typical conversion would be from 115 volt AC to 26 volt AC. AC voltage level to another. So we can use also 26 volt AC. We also need a battery charging. Maintain the state of charge of the aircraft battery by converting 115 volt AC to a 28 volt DC battery charge. So these are the things we can convert from DC to AC power by conversion units. So 28 volt DC to 115 volt AC single phase or the three phase. Another conversion will take place by the transformer rectifier unit, which converts from 115 volt to 28 volt DC power. Also conversion take place from AC voltage 115 volt AC to 26 volt AC for some equipments which are operated at a low voltage like your lights and all. Battery charging, we need a 28 volt DC. So 115 volt AC, which is generated by the main generator, this can be converted to 28 volt DC. Now I will talk about the transformer rectifier unit. This is used to convert the 115 three phase AC to 28 volt DC. This is the purpose of this thing. So here, feed from the primary 115 volt AC bus bar, it will go to the transformer rectifier unit, phase A, phase B and phase C. From here it goes and it is converting from AC to 28 volt DC bus bar, and the DC distribution it goes. Here if you see here, optional temperature status are also there. So TRU or transformer rectifier unit comprises star primary and dual star delta secondary transformer. So here primary star primary and dual star or the delta star secondary transformer windings are used together with three-phase full wave rectifier. Three-phase full wave rectifiers are required to provide the desired 115 volt divided by 28 volt DC conversion. So this TRUs are used to convert, and in this we use dual star or the delta star secondary transformers are required. Power conversion and storage devices. Just I will discuss some storage devices and the power conversion in aircraft. Auto transformers are used, and the battery chargers are used to convert from AC to DC or DC to AC. Auto transformer is certain parts of an electrical system. Simple auto transformers may be used to provide a simple voltage step up or step down conversion. An example of this is a 115 volt by 26 volt AC transformer used to provide 26 volt AC aircraft lighting supply direct from 115 volt AC bus bar in the easiest way. So our lights are working in a low voltage, but our generator is increasing 115 volts. It is generating a 115 volt AC. This AC has to be reduced. 115 volt AC has to be reduced to the 26 volt AC, and a simple step down transformers are used for this purpose. Battery chargers are also there. These batteries, its main purpose are to assist in damping transient load in the DC system. So the purpose of battery is to damp. If any fluctuations of the voltage is there, your battery will assist the DC system to provide power in system startup modes when no other source is available, to provide a short-term high integrity source during emergency conditions, while alternative backup source of power are being brought in line. Now, secondary power distribution. In this, we will have power switching and the load protection. So, power switching at the high power level that prevails at the primary power part of the system. Power switching is accompanied by high power electronic devices called the contactors or ELCUs. Power for switching current below 20 amperes or so, relays are generally used. So if it is less than 20, we use the relays, and if it is high, then we need the circuit breakers and all. So load protection, we have the circuit breakers and solid state power controller. This circuit breaker is shown here. We have here the terminal. Here we will attach the wires here. Here is the housing. Here we have the shake-proof washers are there, mounting units, and this is the push-pull button. If you push, it will be on, and if you pull, it will be off. And this is the white marker band. Here you will see the band here. This will indicate the marker. So now, typical aircraft DC systems I am going to discuss now. The main element of these electrical systems are two 28 volt DC generator operating in parallel to supply number 1 and the number 2 main DC bus bar. These bus bars feed the non-essential DC services. Two inverters operate one of each of the DC bus bar to provide 115 volt AC, 400 Hz to non-essential AC services. Both number 1 and the number 2 bus bars feed power to a center or essential bus bar, which provides DC power for the aircraft essential DC services. An inverter powered off this bus bar feeds essential 115 volt AC load. A 20 volt DC external power source may also feed this bus bar when the aircraft is on the ground without the engines running. The aircraft battery feeds the battery bus bar from which are fed vital services. The battery may also be connected to the DC essential bus bar if required. So here this you can see here, this is the number 1, number 2 DC. From here it will go to the number 2 and the number 3 inverters, generators. Here is the number 1 bus bar. Here is the number 2 bus bar. From number 1 it will go to the non-essential consumers. Here also it goes to the non-essential consumers. From here it goes to the number 2 bus bar. From here this will go to the battery bus bar. Non-essential AC consumer, it will be converted. Then from here it goes to the battery bus bar, and then here it goes to the essential services. Here we have the inverter which will convert from DC to AC, and here also external powers are given. So it is at 28 volt DC layout is shown for this aircraft systems. So a typical civil aircraft, transport aircraft is shown here. It is same way. Here also we have the generator, left generator or main bus bar here, auto land AC, then main bus bar, AC bus bar, and it will go to the different systems, battery charging, hot battery bus. Here is the battery, it is APU battery. All the systems are attached in the different systems. Now electrical loads. So number of electrical services is legion. They may be broadly subdivided into the following categories: motors and actuations, lighting services, heating services, and subsystem controllers and avionics. So here we have the motor actuation, lighting services, heating services, subsystem controllers and avionic systems. So this motor and actuations. So motors are obviously used where motive force is needed to drive a valve or an actuator from one position to another. Typical uses for motors are linear actuation. It is electrical position actuators for engine control, trim actuators for flight control system, rotary actuation, electrical position actuation via screw jacks for flaps slats operations, control valve operation, electrical operation of fuel control valves, hydraulic control valves, air control valves for ancillary system, starter motors, provisions of starting for engine, APU and other systems that requires assistance to reach self-sustained operation. We also use some pumps. These provisions of motive force for fuel pumps, hydraulic pumps, pumping of auxiliary systems, gyroscope motors, provisions of power to run gyroscope for flight instruments and the autopilots, fan motors, provisions of power to run cooling fan for the provisions of air to passenger or equipment. Now I will talk about DC motors. A DC motor is the inverse of the DC generator. It comprises armature, field winding and the commutator brush gears. The main features are the speed and the torque characteristics. Motors are categorized by field winding configuration. Examples are series wound, shunt wound and compound wound. Each of these types of motor offers different performance characteristics. Motor may run bidirectionally depending upon which winding is energized. Motor is particularly useful for powering loads such as fuel systems valves. So these DC motors are used to operate the valves and other systems. AC motors, we have AC motors used for aircraft applications are induction motor. An induction motor operates upon the principle that a rotating magnetic field, a simple rotor sometimes called a squirrel cage, the speed of the rotation of the induction motor depend upon the frequency of the applied voltage. The advantage is that there is always a source of constant frequency AC power available, and for constant rates application it offers a very cost effective solution. AC motors are most likely to be used for continuous operation like fuel booster pumps, flight instrument gyroscope, and air conditioning cooling of the fan. There normally we use the AC motors. Lighting is also very important, and we have seen just now that we use the 6 volt AC for the aircraft. The lighting, there are different types of lighting in the aircraft. We can divide this thing in external lighting and the internal lighting. External means those who are visible from the outside, and internal means from inside where the pilot is sitting in the cockpit and all other cabin and all the cargo doors and all the compartments of the aircraft. So external lightings are the navigation lights, which is on the each wing, red, and this thing anti-collision light on the top and at the bottom. So these are called the navigation light. Strobe lights, they are used to increase or the decrease in the cockpit. Landing and the taxi light, it is on the landing gears at the nose of the aircraft. These landing lights are used. Formation lights, inspection lights, during the inspection for the compartment we have to use. Pilot is also using wing impedance, engine, and anti-icing. Emergency evacuation lights, in case of emergency these lights should be put on. Logo lights for aircraft, your logo should be visible. Search lights for search and rescue for or police aircraft, we use these search lights. They are very high beam lights which can be deflected from very long distance, and object can be seen during the night. If you talk about the internal lightings, these lights are cockpit flight deck lighting, where the pilot is, you want to observe this thing, these lights should be illuminated. Passenger information lights, passenger cabin, general and the personal lighting, emergency evacuation lighting, bay lighting, cargo or equipment bay for the servicing. These lights to be used. Now, heating systems. We also use our power supply for the heating of the system, because during the cold zone, your sensors, your pitot tubes, your windshield, your wings, your engine cowlings, these all things, the ice will be formed. This ice is not good and the performance of the aircraft will be degraded. To avoid that, we should use some heating system so that this electrical heating will try to avoid this formation of the ice. So we should do anti-icing and the de-icing of the aircraft. The use of electrical power for heating purposes on aircraft can be extensive. The highest power uses relates to electrically powered anti-icing or the de-icing system, which can consume many tens of kVAs. This power does not have to be frequently stable and can be variable frequency, and therefore much easier and cheaper to generate. De-icing elements are frequently used on the tail planes and the fin, leading edge, intake cowls, propellers and the spinners. These things are used in this type of scenario. So I have ended this lecture, and I have used the references from the given textbooks. The authors of these things are the Moyer and the Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics Systems. The second book is also from the same author, Moyer and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIA Education Series 2004. Any questions, you are welcome to ask. Please subscribe this channel and also like, give comment if any you want to improve the lectures. This is my email, and try to send this in this any query. Hope these lectures would have been very interesting and very knowledgeable. You might have got some idea. I am thanking you all for listening and watching my this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.